Hey there, how are ya? This is number 6. Okay. So it says the first terms of an infinite geometric sequence U sub n. Let's kind of color code this here, okay? Are 2, 6, 18, and 54. And then the next piece we're talking about here is a second infinite geometric sequence, V sub n, and it's 2, negative 6, 18, negative 54. And then there's a third geometric sequence that comes from adding, it's called Wn, and it comes from adding together the term that you got from the gray one. I've already messed up the colors. The terms that you got from the gray one and the terms that you got from the pink one, B. Okay. So this is where everything is coming from, and then we're given another part here where it says the finite series, and it talks about WK, so that's the yellow one, right? Starting at 1 and ending at 225 can also be written in an equivalent but different form where we have 4 times r to the k. Okay, it looks like we're going to be using that part for the next couple of B and C or so. So let's just like focus on the top couple of parts for the first question, which is write down the first 3 non-zero terms of WK. So the first 3 non-zero terms of WK, well, it looks like WK is made up of U sub n plus V sub n. So let's see how U sub n and V sub n are generated, and maybe we can think of like a quick calculator trick to get this taken care of. And sorry, this is a WN, not a WK. All right. U sub n, let's generate his explicit form. So I've got U sub n is made by, the first term is 2. The common ratio is going to be second term over first. So I've got 6 over 2, which is 3. So I've got times 3 to the n minus 1. Okay? And then Vn is going to be found by, let's make his little explicit formula, Vn. This is going to be negative 6 over 2, so that's going to be negative 3 for my common ratio. All right, cool. So if I want to make Wn, I'm just going to add these two pieces together. So this was gray, this was pink, and to make Wn, I'm going to add together the gray and the pink. So I'm just doing this color coded so you can like see where everything came from. Right, and then I've got this guy. So here's where all the little children came from. All right, here we go. Okay, let's type this in our calculator so we can find the first 3 non-zero terms. Okay, well, let's do it to find like what's W1. We're going to type in our calculator what's W2, W3. All right, let's see what we get. So I've got 2 times 3 to the n minus 1. So for the first one, it would be 1 minus 1, which would be 0. Okay, so the first 2 terms would be, oh, actually everything is like all written out for us up here, so we don't really need this just yet. So I've got first 2 terms added together is going to give me 4. The second 2 terms added together is going to give me 0. The third 2 terms added together is going to give me 36. And then now I'm going to need my little formula after this. I can already tell. So the fourth term is going to be 0. Okay. I need to do this to find W5. W5. All right, so I'm going to do to the 5 minus 1 plus 2 times negative 3 to the 5 minus 1. And I get 324. Okay, so they just want me to take the non-zero term, so I'm going to do this guy, this guy, this guy. So I've got W1 is, or I guess we can just write them out like this. 4, 36, and 324. Okay, that's my answer to letter A. And now B says find the value of R. So R, let's locate R in the question, okay? Let's locate R in the question. I'm going to erase, oops. Okay, here we go. I'm going to erase these pictures here because it's getting kind of loco in the cocoa, but we're going to leave the rest. Okay, so now it says find the value of R. So let's locate R in the problem. Where is R? R is right here. Okay, So R is basically saying, can you identify the common ratio in W? Because it's saying that like this is an equivalent representation of this. And we know that if we took a sigma and we rewrote it where we have a base or a multiplier, that would be the common ratio. So let's go ahead and take, we've got W1, W2, W3, and that is 4, 36, and 324. Let's find the common ratio R. We would do second over first. So we have R is 9. All right, cool. That's where R came from. And now it says find the value of M. So let's find M in the problem. M is up here. Okay, so M is at the top of this sigma right here. Okay. It's saying that this is an equivalent representation of this. So if I'm able to find what this equals, then I can use it to help me find what M should be in the equal but different looking sigma up top. So I've got WK. Let's write WK out as something that we can type into our calculator. So I've got 225. WK is going to come from 2 times 3 to the, in this case, I'm going to change the N to a K because that's where my inputs come from. And then I'm going to do the same thing in the next part. Oops, hold on. This needs to be a negative. Negative 3 to the K minus 1. All right, I'm going to see what that equals. Let me type it in my calculator here. I'm going to use the shortcut you guys showed me, which is where it's in the lobster. See? Look at us learning and growing. It's so beautiful. All right. Oops, look at me. I put the wrong number in there. Let's delete him. Okay. All right. Okay. Whoa, that's a really big number. I'm not even going to be able to identify if I have that number correct or not when I move forward. So let's go ahead and take that gigantic number, pick it up, and we're going to store it as W. Okay. I need what? Okay, we're going to store it as W. Okay. So now whatever this sum ended up being is stored as W. And what I want to do now is see if I have the sum when K starts at 0 and goes up to some unknown M of the series 4 times R, which was 9, to the K. I want to see what M, or I want to see what M up here makes this guy equal the W sum that I just got over here. Because then that will tell me that what M is, right? So like, check it out. This, I feel like I'm not explaining this very well, but you've got K equals 0, right? I'm just typing in the rainbow sigma that I have over here. And then this is M. And then I have 4 times 9 to the K. So this is too many variables, like equals W, like what I'm like solving an equation where this is one of the values that is the input. So let's go ahead and put him in and solve. I wonder if I can do this retroactively, if I'm gonna have to copy it. Let me see. Yeah, I know. But I'm gonna wanna pick it up, so that's why I did that. Okay, so I've got this, right? And I'm trying to see what value of M makes this thing equal that really long W number that I found up top, because then they're equal representations of the same thing. And I'm solving for M. I'm gonna type that in and I get 113. M is 113. Hooray.